Good day. Today we are covering Geometry Lesson 9.2, Angles Inscribed in a Circle. So you're going to be able to recognize the relations between inscribed circles, inscribed angles, and other parts of a circle, such that you can solve for the measure of inscribed angles and the angles formed by intersected arcs. Okay, so that's what we're looking at, and this video supports IXL Skill U11. All right, and please note that you are being given an extension through Wednesday to complete this. Okay. So, obviously this came to you late, even though I did give you a live lesson version of a portion of this video. I'm going to give you an extension so that you can finish it and get it in without feeling overly stressed about it. All right, so the first thing we did was using inscribed angles, and we're going to go through that in a moment, but I first wanted to mention where we left off. We described this for those of you who saw the live lesson. If you want to go through it again, that's fine. And we also we also went through the first example, even though I had set it up differently. And then that's also inscribed angles and their nature, and the nature of the intercepted arc. And then we also did the inscribed angle theorem, so we covered that. And for the most part, most people went through example 2, which is finding the measure of two inscribed angles that intercept the same arc. And then after that, we are into new territory. And we're almost done by the time we get there, but we still have that to do. I also have a couple of upper level problems that come from IXL that are my last two examples in here. All right, so let's look at using inscribed angles, and in particular we're looking at the definitions of an inscribed angle and its intercepted arc. So an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So I drew this. This is a version of what I showed you before. So I drew this circle, and I used a compass to do that. And again, for those of you who weren't around when I did it, let me see what I did with my compass. Here it is. So this is the compass in question that I used. And as I said to the people that I talked to, this is really a great compass. It's less than $10. I believe it's closer to $5. But you can get it fairly inexpensively if you go online to something like Amazon. It stays where you want it to go. It creates a really nice circle. As you can see, it's very accurate. So you might want to use that. It's worth an investment to get it if you have the money to do it. But if not, just sketch your circle. The important thing is to understand the relationships as well as the definitions. So first of all, your inscribed angle is found on the circle. And when they say on the circle, we're talking about the perimeter of the circle, because a lot of people tend to think that the circle also is everything inside. That's not the case. The circle is just the line that you see here. Okay, that's the geometric figure, this line. And when you say on the circle, then you're actually putting your vertex right on the perimeter, wherever it is you want it, but it can be anywhere on the perimeter. And then there are two, of course, rays that come off from that, and inside of it, what I have here in yellow, that's the inscribed angle. Okay. And then the chord is that portion of the side. This is the angle side, but it's you'll notice I wrote ray over here because we have this set up as a ray so that it could go on forever and ever, theoretically, as does this one here, this lower ray that goes from V, the vertex. But the chord is that portion of the ray, or the side, if you will, of the angle that is inside the triangle. So here and here. And the arc that lies in the interior of an inscribed angle, that's this arc, and has endpoints on the angle. That's these two, where the arc stops at these two sides. That's called the intercepted arc of the angle. Okay, let's move on. So, first example, I'm asking, is there a relationship between the measure of an inscribed angle and the measure of an angle of an arc intercepted by the sides of the inscribed angle? So, again, the inscribed angle is right here. Now, I did not finish this drawing because I wanted you to get the benefit of the creation of it so that you would better understand what you're doing. So that's the inscribed angle. And they want to know if there's a relationship between that and the a measure of the angle of an arc intercepted by the sides of the inscribed angle. So the arc, that's this. It's intercepted by the two sides here. So this is the intercepted arc. And to find out if there really is a relation between them, you can see just by looking at this that this angle here is definitely smaller than what you see here. But you really have to find the vertex of the intercepted arc's angle. The inscribed angle and the intercepted arc's angle are in two different places. So where do you go to find the vertex of it? You got to go to the center of the circle. And so I'm going to use C here for the center of this circle. And here's the point. That's the center of the circle. Now, how did I create that? I used the compass. So I know that's in the exact center. So what I'm going to do is I'm going to go ahead and draw using a straight edge. I'm going to use the protractor if I can find what I did with it. Where'd it go? Here it is. I'm going to draw a line that goes from the center of the circle over to where the arc is intercepted by the side of the inscribed angle, and that's right over here. So here's a point here, and I'm going to do it on the other side as well, and it's going to go to the center. So I'm just going to draw this right here and right here. So the actual angles we are comparing is this angle and this angle here, okay? We're trying to determine what the relationship is. So the best way we can do this is to measure it, because we can see that these are two different lengths. Now, I went to great lengths of trying to be accurate, as I said, and that's why I used the compass. So I'm going to measure the inscribed angle. So I'm going to go over here and put this little center hole over the lower point here. I'm going to make sure that the lower line is right on the angle there. And so when you do that, and let's turn this over because we want to be able to see things as they should be and not backwards. So if you'll notice, this angle crosses the protractor at 40 degrees. So this is a 40-degree angle down here, in the inscribed angle. All right. Now let's measure the other angle. This is the angle that's created by the intercepted arc. So I'm going to do the same thing. I'm going to put my center hole here over C. Make sure my line is aligned properly. And then when I do that, let's see here. Let's see. What I may want to do is may want to extend this. So let's do this. Let's extend this line over here in red so that we can read the angle measure, okay? So I'm going to just do this as a dashed line. Okay, so now I can see where it crosses. And you'll notice it crosses here at 80 degrees. So that means that this angle is 80 degrees. So what's the relationship here? The inscribed angle is 40. The intercepted arc's angle is 80. This one's twice what this is. So we can say the inscribed angle, if answering this question, is there a relationship between the measure of the inscribed angle and the measure of the angle of the arc intercepted by the sides? We can say that the inscribed angle, and that's angle V, we only have one point here showing, is 1/2 the measure of angle C, which is the intercepted angle. So intercepted, so 1/2 the measure of the angle of the intercepted arc which is angle C. Okay. Now we can set that up and make an equation from it. Okay. So if we know that this is half of this, we can just say the measure of angle V equals 1/2 times the measure of angle C. Okay. This would be the relationship between the two angles. All right? That's the relationship between the two angles. Let's move on. So that takes us to our rule, and I described that to you. So the rule is, this is the inscribed angle theorem now. If an angle is inscribed in a circle, so this angle here is inscribed in the circle, by definition it's this one here, angle D, or ADB, then the measure is half the measure of the intercepted arc. And so this is the, again, the intercepted arc's angle. Now they're actually looking at this piece out here. It's the intercepted arc, right? So you'll find in geometry they're referring to the arc, but you measure it down here at the center, okay? All right. So that's how we're doing this. All right, pretty simple. Let's move on. Okay, so what is the measure of two inscribed angles that intercept the same arc? Okay. Well, we don't know. Here's actually 3 inscribed angles. I've got angle AE. Oh, we didn't put a, let's see, this is B. We've got AEB, ADB, and ACB. Okay. 3 inscribed angles. How do I know they're inscribed angles? It's because they all have vertices that are on the perimeter. That makes them the inscribed angle. Okay? So angle AEB, angle ADB, and angle ACB are all inscribed angles because their vertices, EIR, pardon me, THEIR, vertices are on the perimeter of the circle. Perimeter, I can't spell. Perimeter of the circle. Okay? So we know then that those are inscribed angles. Also, the inscribed angles intercept arc AB. Oops, AB. So the same arc, right? This is arc AB. So I'm just going to color code that so you can see arc AB there. Now, again, because I use the protractor to be exact about this, I know that the center is right here. You'll notice I drew a dashed, very kind of, it's almost hard to see, dashed lead pestle line that goes from the center up through A and from the center to B. So we'll call this, let me see, we'll call this center F. Okay? So this is center F and circle F. And so since I used the protractor and I was very careful about it, let's measure the angle measure of the intercepted arc's angle. So let's put the cursor on the center of the center point in the circle with a dashed line along the base, and let's follow this up. And it's a little bit off, but let me, actually I was a little off. Okay, so you'll notice it goes through 60 degrees. So that's telling us that this is 60 degrees. Okay? Arc AB's measure is 60 degrees. We measured by protractor. Which is an acceptable way of doing things, okay? So, if we use the definition that, which is this, the theorem that is, that since the measure of the inscribed, of any inscribed angle equals 1/2 the intercepted arc, all right, we don't know what the inscribed angle is, then what we can do is let x equal the measure of the inscribed arc, and let 60 degrees equal the measure of the intercepted, intercepted. I'll just abbreviate because I'm running out of room. Intercepted arc. So what we're going to do is we're going to write x equals, right? X equals 1/2 of 60 degrees. So what's 1/2 of 60 degrees? You can do it in your head probably, but that If you multiply these two together, you get x equals 60 over 2. 60 divided by 2, using your calculator, is 30 degrees. So, since angle E, angle D, and angle C are all inscribed angles, of the intercepted arc, then we can say that angle E equals 30 degrees, angle D equals 30 degrees, and angle C equals 30 degrees. Okay. So those are our solutions. Okay, those are our three solutions. Now, you don't believe me? Well, again, I was trying to be very accurate, very careful. Let's look. So I'm going to put my little cursor over the vertex E, and you'll notice that the angle terminates right at 30 degrees. So that's obviously 30 degrees. And angle D here, same thing, 30 degrees. And angle C, same thing, 30 degrees. So you can see just by using the protractor that our rule again is affirmed, meaning it's proven. Okay, we've proven our theorem one more time just by doing the actual measurements. Okay, so this, if nothing else, should be able to convince you that this is what it should be. Right? It makes more sense when you can see the actual proof in the pudding. Right? Okay, so now we have a theorem about two or more inscribed angles. So this is where most people stopped, and so this may be where now you're going to start again after this particular theorem. So you're going to actually write the rest of your notes on starting with the next screen. So this one says, again, if two or more inscribed angles intercept the same arc, then the angles are congruent. So if you see, we can make the final conclusion then, therefore, angle E, angle D, and angle, this isn't quite mathese, but C, are congruent to each other. Okay? All right. So that gives you everything you need to know from that. And that takes you through this. Now let's go to the last couple questions. So I wanted to do a few upper level questions. So, so what we're going to do is we're going to look at this, and we're going to try to decide what can we use, which of the theorems should we use, or should we use something else. So this is very different than what you had before. Now, you've seen this picture, but notice it's split. This was that arrow, but now there's a split. And what they're telling you is that FGE notice FGE here, is 140 degrees. Whereas FGD, that's 116 degrees. So I'm giving one arc for one and two arcs for the other. Now, they want to know what the measure is of DFE. So here's DFE. It's this. So they want to know what the measure of this is. We don't know what it is. I'm going to give it 3 arcs arbitrarily. Okay. This is what we're looking for. Okay. What's its measure? Don't know. We've got to figure that out. So, we do know that since this is an intercepted, this is an inscribed angle, this particular angle here, we know that it's got to be half of this angle. So we could write here, since angle EFD is an inscribed angle. And why is it inscribed? It's inscribed because it has a vertex on the perimeter of the triangle. Okay. Then its measure is 1/2 the measure of angle, or the arc angle, which is EGD. Now they call it the arc, so we're going to use arc ED. But it's really this angle here. Okay. So it's this side over here. So we want to know what its measure is. How can we come up with this? Well, notice we've got a circle here. All right, well, since a circle has 360 degrees, we can conclude that these 3 angles have to equal 360 degrees. All right? So, since angle FGE, or well, why don't we say, since a circle measures 360 degrees, then I'll put this down here, angle FGE plus, this should be the measure of, and then the measure of angle, let's see, this is FGD plus the measure of angle EGD equals 360 degrees, right? So we can substitute now. Substitute. So you're going to substitute 140 degrees for FGE. So I'm going to put in 140 degrees. And then FGD, so FGD is this angle here, is 116 degrees. And since we don't know what the intercepted arc's angle is, we can say, we're going to call that X, equals 360 degrees. All right? So add these two together. Use your calculator if you need to. So 140 plus 116 is 256. Make sure you saw that, right? Okay. So 256 plus x equals 360. So subtract 256 from both sides. This is real simple algebra, obviously. The 256 and the negative 256 cancel, so you get x equals, and then if I take 360 minus 256, I get 104 degrees. Okay, so we now know therefore the measure of angle EGD, this angle over here, equals 140 degrees. Oh, 104 degrees, I'm sorry. 104, let's rewrite that. 104 degrees. So I'm going to write 104 over here for this angle here. Let's put it out here, 104. Okay, so I know that's 104. Now what I need to do is plug it back into this equation. So let's do that. Let's go over here, and we know that this is EFD again, this angle, inscribed angle. Measure of angle EFD equals 1/2 the measure of angle, or of this arc, intercepted arc ED. And so EFD we'll call X. Let angle EFD equal X. And 104 degrees equal the measure of arc ED. Okay, so we'll change this then. X equals and it's 1/2 the measure. 1/2, and let's put X in red, and 1/2 the measure of 104. So what's 1/2 of 104? 104 divided by 2. If you don't remember, 104 divided by 2. Enter, and you get 52. So X equals 52 degrees. Remember, this is multiplied, and so you're dividing it out. And the easy way to do that is just to take 104 divided by 2. So what you would be doing here, remember this is really 104 over 1. So 104 times 1 is 104 divided by 2. And then you get 52 degrees. Okay? All right. So that one's done. All right. What is the value of X again? So now this is a little different. Here they want to know what X is, but they don't want to know what the measure of the angle is. Over here they wanted the measure of the angle. They call it DFE, and I wrote EDF. Pardon me. We'll just change this to EFD. It's just a reversal. Okay, so the value of X here, well, isn't this is the intercepted arc's angle, right? Here's the intercepted arc. So this is the intercepted arc's angle. Right? And this is the inscribed angle. Okay. So again, use the formula. So the measure of angle RQS, it's the inscribed angle, equals 1/2 the measure of arc and this is arc RS, okay, which is the intercepted arc angle. So RQS, the inscribed angle, is 62 degrees. So substitute. So we're going to substitute 62 degrees for angle RQS, and then we're going to substitute 4x plus 80 for arc RS. Okay. All right, so let's do that. 62 degrees equals 1/2 times, and then the arc is x. We'll put this in parentheses. X, it was 4x, so times 4x plus 80. All right, so we're going to have to distribute the 1/2 to the 4 and the 1/2 to the 80. So we're going to do a little distribution. So we'll distribute the 1/2 to the 4 and we'll distribute it to the 80. So that will be 62 equals, well, what's 1/2 of 4? It's 2. 2x, and 1/2 of 80 is 40. Now subtract 40 from both sides. Let's see, 40, 50, 62, 22 equals, this is canceled, 2x, now divide by 2, and you get x equals 11, which is your solution. Okay? So that's it. Hopefully this gave you a good idea of what some of the more complicated, I should say the more challenging questions in IXL are. These are IXL questions, these two. And they're based on the rules that we've been talking about, and then the simpler ones I showed you earlier. This is it. Have a great rest of your weekend, and remember, this is not due until Wednesday. Thank you very much. Bye-bye now.